In this video, we're going to look at the learning target. I can, given information about the quadratic function, write the equation. So remember, we have three forms that we can write a quadratic function in, and we're going to know which form to use based on the information given to us. So if we look at number one, it says write the equation for a quadratic function that has a vertex at -7, 4 and passes through this point. Since I'm given the vertex, that cues me in that I'm going to write this in vertex form. So I'm going to write f of x equals, and then I notice they're telling me the vertex. So I'm going to plug the vertex into this equation. Remember, the shifts give us where the vertex is, so I can just work backwards. If I have a vertex at -7, 4, that really means that I've been shifted left 7 and up 4. So +7 takes me left 7, and then to go up 4, I need to add 4 to the end. Now, it's important to notice that when you plug into vertex form, that you don't forget the square. Okay, notice quadratics in vertex form have a square on the parentheses, so I need to make sure that that is x plus 7 squared. Now, the last thing to do is to find the vertical stretch, and that's why the problem gives us this extra point over here. Okay, they're telling us it's running through the point -8, 1. So what I'm going to do is I'm going to use this point to find A. And the way it works is the -8 represents my x coordinate, and the 1 is my y coordinate. So I'm going to plug -8 in for the x, and then I know when -8 gets plugged in for x, the function has to equal the y value. It has to equal 1. So this is really going to be 1 equals a times -8 plus 7 squared plus 4. And then I can just solve this equation for a. Well, -8 plus 7 is -1, so I'm going to get a times -1 squared plus 4 has to equal 1. I'm going to minus 4 from both sides. That's going to give me -3 equals a times -1 squared is 1. And then if I take a times 1, well, that's really just a. So I get -3 equals a. Once I have my a, I just plug a back into my formula. So my final answer here is going to be f of x, the function, is going to equal -3 x plus 7 squared plus 4. And then I can kind of just check my answer here. It should make sense. I have a stretch of -3, and then that takes me left 7 and up 4, so it should pass through this point, and or have this vertex, and it should pass through that point. Okay. All right, looking at number 2. So here I have write the equation for a quadratic function that has x-intercepts at 3, 0 and -5, 0 that passes through the point 0, 5. So this time they're giving me the x-intercept, so I'm going to put it in intercept form, okay? And when you write it in intercept form, you got to remember that the p and the q are actually the opposite values. So it's going to be f of x equals, I don't know the a, right? I don't know my stretch, and then I just fill in where the x-intercepts are. So if I have an x-intercept at 3, that really means I have a -3, and if I have a -5, that really means I have a +5. Now, it doesn't matter the order you put those. You could have put the +5 there and the -3 here. What matters is that they're the opposite of the x-intercepts that you have. And then lastly, once again, we're going to use this extra point to find our a. And the way we do that, the x coordinate goes in for the x's. Okay, so 0 is going to go in for both of the x's. And then the y coordinate is what the function's equal to when you plug in the zeros. So this will be a 5. Okay. So we're going to get 5 equals a times 0 minus 3 times 0 plus 5. And then we solve this for our stretch. So when we simplify this, I get 5 equals a. Well, 0 minus 3 is -3. 0 plus 5 is 5. -3 times 5 is -15 equals 5. And then I just simply divide by -15. And when I divide by -15, I'm going to get a equals 5 divided by -15, which can be simplified to be -1/3. Okay, so my a value here ends up being negative 1/3. Once we've solved for the stretch, we can simply just plug that back in for our a, and we'll have our formula. It's going to be f of x equals my a value of negative 1/3, and then I have x minus 3 and x plus 5. Okay, and once again, this should kind of just check out. Negative 3 gives me an x-intercept at 3, plus 5 gives me an intercept at negative 5, and then we solve for that stretch, our a value.